So how do we diagnose a starter motor? Generally, we start off by eliminating everything else. Right? We eliminate the circuit all the way up to the starter motor. We already have a pretty good idea what's going wrong. Okay, our starter motor's not cranking over. Do we have the right amount of voltage available to our starter? Yes or no, right? Do we have enough current being supplied to the starter motor during cranking? Yes or no? And we work through our circuit that way, and if everything adds up on their circuit outside the starter motor, then it's our starter motor. So we can measure the available voltage, measure the starter current draw. We did that down in the shop, right? We can do that pretty simply. Measure the starter circuit voltage drop. Again, when we think about our starter motor, we got our battery, our positive and our negative, going down to our starter motor here. I'll just draw it very rough here. Our negative to the case here. So the terminal on the starter motor. When we're doing our voltage drop test, we would expect to get 12 volts here. And we know we have 12 volts in our battery, we'll assume, because we just did our available voltage test at our battery. You know we got 12 volts at our battery. We should have 12 volts down here, right? There's nothing else in the circuit. So we take our voltmeter and we put it here. What should the voltmeter read? Our voltmeter is only measuring voltage potential difference. Okay, so it should read 0. Okay, so now we start cranking the engine over. What should it read? What's that? Oh. Should there be any voltage potential difference? No, it should be 0, right? When we start cranking the engine over. Because the only voltage drop in our circuit should be the only load in the circuit. Right? The only load in the circuit should be this guy, the starter motor. Right? Because we only get a voltage drop when there is a resistance in the circuit. And the voltage drop is going to be equivalent to the resistance. So we have very, 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 very low resistance. Our voltage drop should be very, 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 very low. That makes sense? Because typically our voltage drop across the starter motor is all the voltage that's supplied, our source voltage. So our voltmeter there should show 12 volts. And if we hook up a voltmeter here, it should show 0 volts. And this is how our voltage drop testing will help us find a problem when the circuit is powered, when we're going to be able to find those resistances when high current is going through the cables and the starter motor. Okay, we already talked about we couldn't do it with our ohm meter. Why? Because our ohm meter only has a very, very small amount of current because of the tiny little battery in it. Because of that, the resistance is not going to show up if it's a small amount of resistance because it's a huge cable. It's designed for high current. So the only way we can test that circuit is by passing high current through it and then measuring the voltage drop in that circuit, which will then tell us there's a resistance in there that we can't see. That is only there during high current application. Does that make sense? So now if we test this between our battery positive here and our terminal on the starter motor where our battery connects, if we see anything more than, I think it's 0.5 volts is the spec, no matter how long the circuit happens to be. That's the maximum voltage drop we should have through all this cabling, through the solenoid, through the relay, through whatever there happens to be in the circuit, 0.5 volts. Because connections are supposed to be 0 volts for connections. And it's 0.1 volt per foot of cable. And we shouldn't have a starter motor circuit where we've got more than 5 feet of cable from the battery positive to the starter. If we do, maybe there's something wrong there. But still, even if we had 0.6, and we shouldn't really have a starting problem based upon that small amount of voltage drop. If we see more than this, we probably have an issue there, a bad connection. And how are we going to track that down? So let's say we got a relay in here. Okay, here's our relay. Again, I'm just going to draw it just quickly just to get the idea. There's our starter relay. Now we can go back here. We can go, okay, let's say we got 4 volts here for our voltage drop. Way too much. From here to here, we got high resistance in that circuit. Our starter motor, when we're cranking it, is only going to get the remainder of our 12 volts. 12 volts less the 4 volt drop across here means our starter motor is getting 8. It's not going to work. Not properly anyways. So now we're going to go back to our circuit. We're going to take our voltmeter. We're going to go from there to there. That should be 12 volts. That should be 12 volts. What should our meter read? 0. If it reads anything other than 0 or maybe 0.1 volt, there's something wrong in that cable. It needs to be replaced. Now let's see we get 0 volts. Now we're going to take our cables and we're going to go like this. We're going to go from, here to here. We're going to operate our starter motor. We should get 0 volts. That's a switch. So connection. Okay? Should be 0 volts. If we get anything other than that, that relay's bad. It needs to be replaced. Okay, but don't just go ahead and test one component and then replace it. Go through the whole thing. Because you need to find that 4 volts. So if I get, let's say, 0.3 volts drop across my relay, okay, that's a problem, but that's not the whole problem, right? Find the whole problem. So then we're going to go here. I'm going to check from there to there with my voltmeter. And somewhere between here, there, or there, my 4 volt drop should show up. Make sense? So this is how voltage drops are going to tell us exactly where the problem is. And we have to do that loaded, drawing the full amount of current to operate that item. So while cranking. Because remember, our voltmeter is just measuring the voltage potential difference. It doesn't care where it's connected. Again, down here on our negative side, we might have a connection from our starter motor to the frame, and then from our battery to the frame. So we can have a bad connection here, here, or possibly, depending upon whether it's connected directly to the frame or to a cross member that then is connected to the frame. I've actually had bad connections between a cross member and the main frame rail cause a starter motor issue. Okay, so don't assume that a cross member bolted to the frame is a good connection. You can find out in a hurry. Do a voltage drop test. So again, starter motor problem, you go and check from here to here. On the positive side, you're expecting to get 0 volts. You get, let's say, 0.1 volt. When you go from here to here. 0.1 volt from there to there, voltage drop, that's okay. So now we got 12 volts to our starter motor. Pretty darn close, right? Within 0.1 of a volt. So is the problem on our ground side. Again, voltmeter from there to there should show 0 volts. If it doesn't, now you're going to go, let's say it shows 4 volts now over this side. Again, starter motor case to the frame. Do a voltage drop test. Right? Crank it over. See what the voltage meter reads. If it doesn't read 0 volts, you got a problem. If it reads 0 volts, then you're going to check from our battery to the frame over here. Does that show 0 volts? If it doesn't, you got a problem. If those bolts show 0 volts, then you're going to go from the frame connection here to the frame connection here, and eventually you're going to find where that 4 volt drop is, because that's a resistance that only shows itself when there's a high current draw. And this is why voltage drop testing is probably one of the most valuable tools or tricks that there is in the trade when diagnosing electrical problems. Okay, does that make sense? So we're going to do voltage drop testing down in the shop because this is how important it is. And there's some neat tools that are on the market for doing that too. That does most of the thinking for you. You just got to make your connection points, right? You can diagnose a starting circuit in less than a minute, maybe 2 minutes, if you have this tool that I'll show you the tool later. It's pretty cool. But it's basically doing the same thing. You don't need the special tool. You can do it with your voltmeter. Yes? You had a question? No. So voltage drop testing, so inspecting and testing starter control circuit. Again, inspecting and testing starter control circuit is going to be an issue if you have no crank. Right? The control circuit is going to factor into that. Because if you turn this key and you don't hear the click, click, click of the solenoid or the relay, then you know you've got some control circuit issue somewhere else. And then you're going to have to go then inspect and test the relays and solenoids. Again, that's going to be pretty straightforward, I think, right? See somebody looking at the clock. Are you done yet? Almost. Okay, see, it sounds pretty obvious, but just for the record, we're going to say, make sure you check the ring gear and the starter drive when you have it out, right, if there's any damage. I have seen lots of times where there's a few teeth missing on the ring gear, and there's an intermittent starting issue. You know, like crank, 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 no problem, crank, 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 crank. And then by the time you hit the starter motor, it just goes, zing, like nothing, right? There's probably some teeth missing off the starter, off the ring gear, but it could be a bad starter drive too, right? So don't just go replacing the starter drive, assuming that's the problem. Well, you have the starter motor out, bar the engine over, and look at all the teeth on the flywheel. Even if you have to get out your paint marker and mark the teeth and crank the engine over. Now, it's a good practice to do that, even if you're replacing the starter motor for some other reason. Because the guy may have had that problem, and I've run across this, okay? He comes in with one problem, and there's actually two problems, but you can't see the second problem because you haven't fixed the first problem yet. You can do that one of two ways. Tell your client, yeah, I know the starter motor is bad. Once you put the starter motor on, then we'll see how it works. And then we'll test the rest of the system. Okay? Actually, there's three ways. The other way, you can ask him if he's been having problems before he got there, right? Okay, it doesn't start right now. Were you having problems before this? Yeah, before I brought it in, I used to crank the engine over. Every once in a while, I turned the key, and the starter motor would turn, and it wouldn't turn the engine. Okay, so maybe there's another issue there first, right? Or, while you're doing the job, you can look at every little thing, right? Pull the starter motor out, bar the engine over, check to make sure all the teeth are on the flywheel, and then if they're all there, then once the starter motor's put on, if that was your fault, then you've corrected the guy's problem, right? Because you've tested all the other stuff first.